Lanthanum oxide is La2O3, an inorganic compound containing the rare earth element lanthanum and oxygen. It is used to develop ferroelectric materials, as a component of optical materials, and as a feedstock for certain catalysts. Properties: La2O3 has a band gap at approximately 5.8 electron volts. It has the lowest lattice energy, with very high dielectric constant, epsilon equals 27. La2O3 is widely used in industry as well as in the research laboratory. Lanthanum oxide is an odorless, white solid that is insoluble in water, but soluble in dilute acid. Depending on the pH of the compound, different crystal structures can be obtained. La2O3 is hygroscopic. Under atmosphere, lanthanum oxide absorbs moisture over time and converts to lanthanum hydroxide. Lanthanum oxide has p-type semiconducting properties. Its resistivity decreases with an increase in temperature. Its average room temperature resistivity is 10 kOhm/cm. Structure: at low temperatures, La2O3 has an Am2O3 hexagonal crystal structure. The La3+ metal atoms are surrounded by a 7-coordinate group of O2- atoms. The oxygen ions are in an octahedral shape around the metal atom, and there is one oxygen ion above one of the octahedral faces. On the other hand, at high temperatures the lanthanum oxide converts to a Cm2O3 cubic crystal structure. The La3+ ion is surrounded by a 6-coordinate group of O2- ions. Elements obtained from lanthanum. There are several elements which were discovered as a consequence of the lengthy analysis and breakdown of the ore gadoliniite. As the ore was progressively analyzed further, the residue was given the label thence ceria and thence lanthanum and onwards to yttria, erbia, and terbia. The list by date includes cerium 58, lanthanum 57, erbium 68, terbium 65, yttrium 39, terbium 70, holmium 67, thulium 69, scandium 21, praseodymium 59, neodymium 60 and dysprosium 66. Several of these new elements were either discovered or isolated by Carl Gustav Mosander in the 1830s and 1840s. Synthesis: lanthanum oxide crystallizes as several polymorphs to produce hexagonal La2O3. A 0.1 m solution of LaCl3 is sprayed onto a preheated substrate, usually made of metal chalcogenides. The process can be viewed as occurring in two steps: hydrolysis followed by dehydration. 2 LaCl3 plus 3 H2O La3 plus 3 hydrogen chloride, 2 La3 La2O3 plus 3 H2O. An alternative route to hexagonal La2O3 involves precipitation of nominal La3 from aqueous solution using a combination of 2.5% NH3 and the surfactant sodium dodecyl sulfate, followed by heating and stirring for 24 hours at 80 degrees Celsius. 2 LaCl3 plus 3 H2O plus 3 NH3 La3 plus 3 ammonium chloride LaCl3 3 H2O La2O3. Other routes include 2 La23 plus heat 2 La2O3 plus 6 SO3 reactions. Lanthanum oxide is used to develop ferroelectric materials, such as La doped by 4. Lanthanum oxide is used in optical materials. Often the optical glasses are doped with La2O3 to improve the glass's refractive index, chemical durability, and mechanical strength. 3B2O3 plus La2O3 2 Louisiana 3. When this 1-to-3 reaction is mixed into a glass composite, the high molecular weight of the lanthanum causes an increase of the homogeneous mixture of the melt, which leads to a lower melting point. The addition of the La2O3 to the glass melt leads to a higher glass transition temperature from 658 degrees Celsius to 679 degrees Celsius. The addition also leads to a higher density, microhardness, and refractive index of the glass. Uses and applications. La-2O3 is used to make optical glasses, to which this oxide confers increased density, refractive index, and hardness. Together with oxides of tungsten, tantalum, and thorium, La-2O3 improved the resistance of the glass to attack by alkali. La-2O3 is an ingredient for the manufacture of piezoelectric and thermoelectric materials. Automobile exhaust gas converters contain La-2O3. La-2O3 is also used in X-ray imaging, intensifying screens, phosphors, as well as dielectric and conductive ceramics. Gives of bright glow. La-2O3 has been examined for the oxidative coupling of methane. La-2O3 films can be deposited by many different methods, including chemical vapor disposition, atomic layer deposition, thermal oxidation, sputtering, and spray pyrolysis. Depositions of these films occur in a temperature range of 250 to 450 degrees Celsius. Polycrystalline films are formed at 350 degrees Celsius. La-2O3 tungsten electrodes are replacing thorianated tungsten electrodes in gas tungsten arc welding due to safety concerns with thorium's radioactivity.